Welcome to Klein's Geometry. Today we're going to talk about properties of polygons. And the first thing we want to do is review the definition of a polygon from lesson 2.4. And it is a closed plane figure, which tells you all the sides are connected. There's three or more line segments. They're straight sides. That's what that line segment means. And the sides can't cross. So looking in front of you, you see polygon ABCDE is a polygon. It is a closed plane figure. All the sides are connected. The sides are made out of lines, and none of them cross each other. So we've got some parts. The first thing we look at is vertices. A, B, C, D, and E are the vertices of the polygon. So we could list them just like any other point. They're the points where the line segments meet. Now the sides are line segments. They connect the vertices. So AB is a side, and we can name it with a segment symbol over the top. BC, again. CD, DE, and finally segment EA or AE. Order doesn't matter, you know that. And then the last thing, something you maybe haven't thought about, is the diagonal of a polygon. From A, if I connect it to the vertex B, it's a side, but if I connect A to C, that is a diagonal. And I could also draw a diagonal A to D, B to E, B to D, or E to C. So we have a lot of diagonals here. A to C, I think we said, and A to D, and we've got to put the segment symbol over those. B to E, B to D, and then we had that fourth one, C to E, and we already had CA and so on. So there's our diagonal. If I want to name this polygon, I start at any letter, any vertex, and I name it like I would trace it, starting at A to B, C, D, E. So that could be polygon A, B, C, D, E. I could start anywhere though. So I could start at B if I wanted, and I could go either clockwise or counterclockwise. If I wanted, I could trace it to C, but then I'd have to go to B and A and E. So you have to name it as if you would trace it. So lots of names for this particular polygon. Okay? Now when you talk about types of polygons, we can classify them by the number of sides. I'm sure many of you have seen lots of three-sided polygons, and we call those triangles. When we think about tricycle, TRI stands for three. When we think about four sides, we're talking, I always think quad, because my boys had quads growing up, those four-wheelers that you just fly around on. So quad were lateral, remember? Lateral means side. So four-sided figure is a quadrilateral. Five sides is a pentagon. 5 letters, penta, and the prefix, 5 sides. A hexagon is a 6-sided pentagon, and I always think 6, there's an X in hexagon, so you kind of remember it that way. 7 is a heptagon. I used to get hexagon and heptagon mixed up till I realized there was an X in hexagon and in 6, and hepta has more letters in the prefix than hexagon, and 7 is more sides than 6. 8 is easy. It's an octagon. Think about an octopus with 8 legs. 9 is also easy. It's a nonagon, and non and 9 sound a lot alike. When you think about 10, think about a decade, and you have a decagon, because deca means 10. And now for 12, I need 2 more than 10. So 2 more letters than deca, and I've got dodecagon, and that's my 12-sided polygon. If I had any number of sides except the specials up here, I just call it an n-gon. A polygon with 11 sides is an 11-gon. With 20 sides, it's a 20-gon. With 50 sides, it's a 50-gon. So anything other than these specials, just whatever it is, gone. Now let's look at these polygons. Which of these are polygons? You want to be able to identify them. First, it said a plane figure, so you know it's got to be a two-dimensional figure. It can be drawn on a sheet of paper. We want to know, do the sides connect? Are they straight? And they can't cross. Look here, fits all three criteria. Yes, it's a polygon. Here, the sides cross. So that's a big no. Here, the sides curve. And they have to be straight. So there's another no. Here, they connect. They're straight. They don't cross. Here's a yes. For E, we're crossing all over the place. They cross here and here and here and here. Big mess. No. Sides can't cross. And finally, for F, what do you think? Saw the curve, right? No curves allowed. This is also no. So, look at that definition and just make sure anything you think is a polygon fits these three criteria. Sides connect, they're straight, and they don't cross. And now let's look at the ideas of convex versus concave. In a polygon, if all the diagonals are inside the figure, it's convex, it's blown out. I can draw my diagonals, and wherever I draw them, they're inside the figure. So this is a convex polygon. Now in this polygon, I can draw a diagonal outside the figure, inside, but I can also draw this one outside the figure. If there's one outside, it's concave. I think of it as caved in right here. Okay? And when you think about a regular polygon, regular means it's really predictable. All the sides are congruent, all the angles are congruent. Same. If it's irregular, at least one side or angle is not the same as the rest. And all it has to be is one. So let's look at this. Look at A. Is it regular or irregular? Well, I look, all the angles are the same. And now I look at the sides, all the sides are the same. I'm looking at the tick marks. Don't look at my drawings, because I don't do good drawings. But according to these little right angle symbols, we got same angles, same size sides. So we would say it's regular. And then convex or concave, well, if I drew diagonals, those are my only two diagonals. They're inside the figure, so it's convex. For B, regular or irregular, I see all the sides each have two tick marks. So all the sides are congruent. And all these marked angles are congruent. But I know that there's an angle in here that's really a huge angle. It's definitely not like those. So since this is even one angle, and I see there's actually quite a few, there's four of them. So I'm going to call this irregular because this angle's not the same as that one. Now when I look at my diagonals, well, I can draw diagonals inside the figure, but I can also draw diagonals outside the figure. So if I can draw a diagonal outside the figure, it's concave. You can see it caved in right there. Looking at C, I see two angles that are the same, but I don't know about this one. And you can assume, so right there, that's as far as I'd have to go to call it irregular. Now you might go a little further and say, well, Mrs. Klein, look, these sides aren't the same, so it can't be regular from that. True story. So however you want to do it, there's plenty of stuff that's different measures in this. Now when you talk about concave or convex, well, I see this diagonal outside the figure, So it's going to be concave, all caved in right there. You can see it coming in right there. So hopefully that helps you. Concave, one diagonal outside, regular, all the sides are the same. Polygon, straight sides, all connected, they can't cross. Learn all those nice names and you are in good shape.